divide by 0 and define instead of 0.
We had to answer that on our homework, right?
I think the best way to describe it is you cannot divide 0 things into 0 groups. There is nothing that you're doing. Like, it's not a number because nothing's happening.
Okay.
I just, like in high school, we always taught, like, you can never divide anything by 0, because it's like saying, how do you split something into 0 parts? It's impossible. Even if it's nothing, you can't split it into nothing parts. And so that's why it's undefined, because there isn't a way for us to actually say that it's 0, because
I think I'd accept either one of these. There's a more powerful and I think a little more understandable one. Keep going. Anybody?
On Friday, we talked about one of the ways to do it would be using the missing add-in. That made the most sense to me.
Missing
factor.
Okay.
I have that in crossed off, factor. So if, like fact family, so we know.
Let's get the other members of the fact family up here.
3 times 3 is 6.
3 times 2 is 6. Then
6 divided by 2 equals 3.
and
6 divided by 3 is 4.
okay. Can everybody do this with known numbers so you can get a pattern? If you ever get on a quiz or a test and you're dealing with fact families, write down one that you're comfortable with. So now, if I've got 0 divided by 0 equals blank, and we're trying to figure out what the answer is, put it in a multiplication member of the same family. So how do we do that?
0 times blank equals 0.
Which 0?
First 0, it doesn't really matter.
It does.
Well, I
It
would
does
normally do the
matter.
first
They're
zero.
both zeros, but it does matter which 0. 0 times blank equals 0. Which 0 is this? This one or this one?
First. The second.
Look over here. When you're dividing, the dividend in both division problems is the product in the multiplication ones. So this one here is that one. Does that make sense? And this one is that one. And you say, well, it doesn't matter. Yes, it does. If they are
Actual numbers.
members of a fact family, you've got to put the right one. So this is saying, what would I multiply by 0 to get 0?
And then
7. Negative 3. Square root of 11. Whatever you want goes in here. Since there's not a number, a single number in there that makes that true, this is undefined. The same thing is if you're doing 0 divided by 6 equals what? And you want to know, what do? Write the missing factor member of the fact family. What is it? Follow the pattern.
6 times blank.
6 times blank equals 0. Is there an answer there? 0 is the only number that will work, right? So if this is 0, then this must be 0. If I can put any number I want in here, this has got to be undefined. And what about this last one here? 5 divided by 0 is blank. What's the answer there? Well, missing factor would be 0 times blank equals 5. What goes in there? Nothing. There, because if I multiply by 0, I've got to get 0. So there's not a thing I could put in there to get a 5 out. This one is undefined because there is no answer. This one is undefined because there are infinite number of answers we could put in there that would work. Okay? So both of these are undefined, but for different reasons. Okay? This one is defined. The answer is 0. Okay? I think one of your best ways to go about that is with the missing factor model, looking at it. That helps to answer it. Now, there were other ways of looking at it, and we did that on Friday, and if those of you who weren't here on Friday, I think the video is posted on YouTube, and all you got to do is go in and type in my name, and did you find it? It was there. And so we talked about how you can think about that through not only the missing factor model, but the partition sharing model, or the measurement or repeated subtraction model. We talked about those. If those of you who weren't here need that, you can go there and get that. Okay? Any more from the quiz? Did everyone get the one that sometimes when we're dividing, we really don't care about anything but the quotient? We totally ignore the remainder. Sometimes we look at the quotient and the remainder and round the quotient up 1. Sometimes we just look at the remainder. In each situation then that we have, dictates what we try and do there. Okay? That's all for the quiz. Let me see here. Did everybody get their test back then? Except for, oh. I'm sure this gone today, right? Now, Devin, you had a question, but it's about the test I just handed back. Can we cover the material that I need so you're able or ready to do your homework, and then if there's some time, and there should be, we can talk about that?
It was just one of the question about the bonus questions in the back. I didn't know if they were graded at all.
They were. If you didn't get any points, there were no points showed up there. If you had one, there should be a plus by each individual one and how many points you got from that. Please add up the score. My math is pretty good, but once in a while I make arithmetic errors. Anyway, add those up, make sure, and then look them over, and if there's any that you missed and you don't understand why, or why you missed as many points as you did, please see me about them. And yours is on its way. Okay. We could entertain some questions about that test as soon as we finish. Let's talk for a minute about integers and division of integers. How would you help students make sense of it instead of just memorizing some rule? We talked about this a bit.
Like a number pattern.
A number pattern. Okay? Does everybody have a number pattern that would work? There are plenty of number patterns that won't work. Let me give you one. Number patterns. If we're going to use a number pattern, we've got to start with something the kids know and are comfortable with. So, if I did this, would they know that? Okay, so I'm meeting the first rule. Then I go 6 divided by 2. Then what? Do they know the answer to that? All right. What's next? Class?
6 divided by 1.
6 divided by 1, and the answer is? 6. What's next?
6 divided by 0.
6 divided by 0. What's the problem here? Are the kids in the known now?
They're probably in the unknown.
They're in the unknown, or at least most likely they are, because they don't understand about what dividing by 0 is undefined. And they're not going to be able to get the answer from our pattern. This pattern goes from 2 to 3 to 6. We don't know where it's going to go next, right? You follow me? This pattern is not helpful. Even though it started with the known, it didn't use a pattern that developed something that would carry them into the unknown. So what do we do?
Don't you keep the second number constant and the first number can change?
Okay. If we're going to use division, that's the pattern we're going to have to do. So if you want to use 6, let's go ahead and use 6. We'll go 24 divided by 6 equals 4. We'll keep this the same. We'll make this 18 is 3. 12, and it's 2. What's next, class? How do they know? How are they going to know it's 6?
They're going down by multiple of 6.
Down by 6, down by 6, down by 6. This is staying the same. What's the answer?
1.
They'll know the answer to this one, right? If you've taught them how to divide whole numbers, they'll know. Then what?
0 divided by 6.
0 divided by 6, and what will the answer be?
0.
There's another reason why the answer here is 0, right? The pattern gives it to us. What's next? Negative 6 divided... Do you think they can do that? Yeah, they can. And what's the answer now? And they don't know how to divide negatives and positives, but they'll know the answer is
2 or 1.
negative 1, because the pattern takes us there. So there are some patterns you might try and attempt that don't get you to where you need to go. They don't accomplish what you need to go. This could be helpful. So we've got these problems where we say, when do we get a positive quotient? Well, when the two numbers are positive, and they'll know that from the whole number. When do we get negative quotients? And this will be, we could continue on here. We get negative quotients when we have a negative number divided by a positive, and so on. So that helps a bit. But then we said there was something that probably helped even more. To help them make sense of it, not memorize it. Fact families. How? If you have worked with them well on multiplying integers, and they understand that well, and they're just not memorizing it. But by the way, what do most teachers do when it comes to dividing integers? Come on, probably happened to you. It happened to me.
I don't remember that far back.
You don't remember that far back, junior high.
Well, mine kind of said divide it like you normally would, and then
Ignore the signs and divide the numbers.
and then if one of the either the divisor or the dividend has a negative sign, then put it there. If only one of them does.
If one of them has it, write a negative on the answer, right? Okay, that takes care of if one's one and one's the other. Then what'd she say? That's part of the rule.
Then if they both have a negative, then it's then we make it positive.
Then the answer is positive. So if you have two negatives make a positive, they'd say, a lot of teachers, right? Well, it's true when you're dividing, right? But that's a rule that you memorize. And two negatives don't make a positive when you're adding, do they? And kids get those rules running together. And when you're subtracting, if I take a negative and subtract a negative,
You're actually adding. And then you
I can actually get it to be a positive. Yeah. Negative 2, subtract negative 11. That is a positive 9. So a negative with a negative on subtraction is also a positive. This time, right? Do you see what I'm saying? If they're memorizing rules, then it all runs together and they don't make sense of it. Try and help them make sense. Here are some ways. So what do? We've got them to understand the rules for multiplication. And then what we're going to do is we're going to write a problem. We're going to say negative 20 divided by 4. And we could have developed that through a pattern over here, right? We could have started out with 20 divided by 4, and then 16 divided by 4, and then 12 divided by 4, and come all the way down to negative 20 divided by 4, and they would know the answer. But let's just say you're starting off cold. What's the answer? We don't know. But let's use a fact family to help us. What is the fact family member that we're after? Or a fact family member that would help us?
4 times blank equals
4
20.
times blank equals negative 20. Okay. What am I going to have to put in the blank to get this to be a negative 20? And if you've covered and they understand the multiplication rules before you move to a division, they're going to know this is a negative 5. So we'll put this problem up. They'll write this and they'll say, oh, if that's negative 5, this must be negative 5. Otherwise, it couldn't be in the same family. Then we'd put another one up. Let's do one like this. Let's do... What's the answer? Well, I don't know, because I don't know my division rules. I haven't invented them yet. So I'm going to write what?
Negative 3 times blank.
Negative 3 times blank equals 15. Well, if I've got my multiplication rules that I've developed, that I've invented, I know this has got to be a what?
Negative 5.
A negative 5. Therefore, this has got to be a negative 5. Now we can start looking and saying, you don't need to tell them this. They'll come up with it. They will invent, well, whenever I'm dividing and one of the numbers is negative and one's positive, I get negative. Whenever one is positive and one's negative, I get a negative. And they will, you just put a whole bunch of those patterns on the board and they come up with it using the fact families. Not only that, if they ever forget the rule they invented, guess what they can do?
They can figure
Go
it out.
back and reconstruct it using the method that they used it with. Now, do we want them to be fluent so that they can do it quickly? Yes. But give them opportunities to understand it. Okay. What about decimals? Here we go. What are you going to do and how are you going to help kids understand what to do and why you do it that way? In other words, sense-making mathematics. If you can't make sense of mathematics, don't teach it. That's pretty harsh. Who knows what to do? Let's go there. Rebecca?
Well, when you have a decimal, you have to make sure that the number, I'm probably reading the terms now, but the number that's going to be on the outside of the divider, I'm
can't remember, but it's the number, you have to.
Help her.
It's a whole number, it has to be a whole number.
The number that's being divided into the number has to be a whole number.
Okay, what do we call this right here? I've heard teachers call it the divisor house. It's the house. And this is outside the house and this is inside the house. And I think it has a term, it's slipping my... But what's this number out here called? We better know that. Divisor. And so which one of these goes there?
1.35.
Why does it? Because it's the smallest one?
No, because it's the last one listed.
Because this says this divided by this, and when we divide by, the divided by has to go out here, the divisor. And we put this one in here. Okay, Rebecca, continue.
Okay, so to make, when you have a decimal number, it's kind of hard to determine, you know, like 1.35 actually does go into 4, but it doesn't work right, so you have to convert the 1.35 into a completely whole number.
So how do I do that?
So you find how many, you have to figure out how many places to, I'm totally getting tongue-tied here, it's so hard to explain.
You're okay.
You have to determine how many place values to get the whole number. So since there's 2 decimal points, 2 places after the decimal, you have to do it times it by 100, or move the decimal point 2 places. It's the same exact thing. And then you do this just as you do with the divisor. You have to do it with the dividend.
Okay, so I have to move this 2 places.
Yeah.
Now what do I do? Move this straight up and then start my division, right? Okay. Now, that's what we do. Jamie, question?
I just have
comment?
a question. If you wanted to get rid of that decimal completely, could you? By just multiplying by 1,000 instead of 100?
So move this over here.
Move that over 3, and then on the 1.35, move over 1 more and put
So
a
it'd be
0.
1,350? Could you?
Yes.
Yes, you could. Is there any reason why we would not want to?
It's more work.
How is it? You're right, it is.
You're adding another decimal point that's not really needed.
You've got a bigger number than you really need to go into, but it would work. Okay? Now, why does it work? So were you raising your hand to make a comment or ask a question or what?
Well, I mean, wouldn't they be confused, like, because like all this other stuff's like detailed, and this ones were just like, oh, move the decimal place, like,
Yeah,
shouldn't they like?
and most teachers teach this, and they stop right there. So what if your student says, well, why do you move the decimal? Well, because you want this to be a whole number. Well, yeah,
Like, well, why does that make all this?
but why do I move this one 2 to the right and this one 2 to the right? Why don't I go 2 to the right and 2 to the left? Or whatever.
Well, you want to keep the measurements the same, and so if you're multiplying by 10 on one side, then you have to multiply by 10 on the other, and that's making the number bigger. And the original number, 487.658, that number is just getting bigger by 10, so it's 4,876.5, and then the decimal place is just moving over. Does that make sense? It doesn't. Okay. Like, you want to keep the measurements the same. Like, it's just like if you're having a recipe and you're doubling the recipe, then you're keeping the measurements the same, you're just doubling them. So on this, you're just multiplying it by 10 or 100, but you're doing it to both sides, making the number bigger, so it makes
So
more sense.
why should I do what outside here, multiply it by the same thing that's inside here? What, mathematically, what tells me I should do that?
Because if you're growing the outside number, then you have to grow the inside number as well.
Why?
To make it,
So that the equation stays the same.
yeah.
Let's look at it this way. I can write divided by with this symbol, right? I can write divided by with this symbol. I think it's called a circumflex. It just came to me. But or what else? What other symbol can we use for divided by? Come on. A fraction bar. So I could write this as which one on top and which one on bottom? You got to know that.
The 135 on the bottom.
So we've got 487.658 divided by 1.35, right? Okay. Now, we've learned about the multiplicative identity. Correct? What is it? Stephanie? 1. Why is 1 the multiplicative identity? Because it does nothing when you multiply by 1. So I can multiply this number, this fraction, by 1, and nothing happens to it. Do you agree with me? You multiply it by 1? All right, I'm going to pick a very special form of 1. Do you agree that's the number 1?
Yeah.
Okay. So if I multiply this number by 100, what happens? I get 135. When I multiply this one by 100, what do I get? 48,765.8. Right? Does everybody see what? That's the reason why we're moving those the same number of places, because this could have been written as a fraction and I'm just multiplying it by 1. Okay? Which, Jamie, going back to your question about could I multiply top and bottom by 1,000? Sure. That's the number 1. It will give me the answer. If I do it appropriately, it will give me the right answer, but it will be more work. But I could. Okay? So if your students say, well, why do you move the divisor decimal point the same number of places as you do the dividend decimal, you can just convert this to a fraction and show them that that's the reason. Okay? That helps them to, by the way, when it comes to multiplying and dividing numbers by, or decimal numbers, it's probably a real good idea to estimate them. In fact, grab your calculator and don't touch your decimal button at all. Just go 487,658, hit divided by, and then 135. No decimals at all. Just don't put any decimals. Get the answer. 487,658 divided by 135. What did you end up with?
3612.
Pardon? Start it off.
Sorry, 36.
3,
12.
6, 1, 2.
Point.
Point? Oh. Okay. Point? This one divided by this one.
Mm-hmm.
Okay, so, all right. So leave the decimal out and just give me the answer here.
2814.
814.
814.
And it probably keeps on going, right? Okay.
814.
Where would I put my decimal point in here that would make sense? We're talking about a number just a little bit bigger than 1, going into a number that is a bit bigger than 487. The answer should be, if it's 1 going into 487, it should go in 487 times, right? Well, what number is closest to 487 here? That decimal point there, 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 where? Should I put another 0 in 487? Where do I put the decimal point so that I'm closest?
It would be, have to be,
Right there, right?
no, one more over.
361 is not closer to 487
But it's
than...
under.
Huh?
So it's under, so it wouldn't count. 361 is under 47.
That's because this number's a little bit bigger than 1, so it's going to go in a bit fewer times than 487. Does everybody get what I'm trying to... The answer's got to be close to 487. And I maintain that 361 is closer than 3612 point. That's not closer to 487.
But that's the correct answer on the.
That's the answer when you did it with no decimals. But we're not dividing 135 into 487,658. We're dividing 1.35 into 487.685. So we can place the decimal by just estimating, not by moving decimals and raising it straight up and so on. But can everybody see that? How we...
So after we divide, we have to turn the decimal back to where it was? Is that what you're saying?
I'm saying ignore the decimals completely here.
Okay.
In our mind, we know the answer is going to be around 487. Because 1 goes into 487 times. So when I get this big string of numbers, I'm just going to put the decimal so that the quotient is closest to that number.
Okay.
And that is right there. Because that's a lot closer, 361 is closer to 487 than 3,612. Does that make sense?
It makes sense, but I was never taught that, so I'm really confused.
Let's try another one then. How about 22.146 and dividing it into 58.3469. Grab your calculators, don't touch the decimal button. Let's put another number here just so that we can go 58,34692 divided by 22146. Don't touch your decimal button, just get the quotient. What do you get?
263,464,824.
Okay, we can place the decimal properly without messing around with moving this one 3, moving this one 3, moving it up and doing the division. Because I know that 22 goes into 58. Well, it would go into 44 twice, and it would go into 66 3 times, right? So my answer is somewhere between 2 and 3, right? Does everybody agree? Well, where do I put my decimal point so that I have a number that's between 2 and 3? 2.6. That's how I place my decimal point. Does that make sense? It's kind of like this. Let's do the reverse. If I'm multiplying this number times this number, I could do that, and I could get, I could count how many decimals are in this factor and how many are in this factor, and then I've got to have that many in my product, right? But why can't I go a number that's about 3 times 22, that's about 66. Where would I place my decimal here so that this number is closest to 66? I would place it there. Does that make sense? You don't need to try doing this problem. 46.38 times 5.89. I could multiply 4638 times 589, no decimal in my calculator. Go ahead and do it. Just leave your decimal off, but this is times this time. Give me the answer.
31782.
Don't worry about counting the decimals in your 2 answers and count. No, just say this number is about 6, right? And we can do this even fairly general. This number is about 45. 45 times 6 we can do in our head. 2 45s is 90, right? So if I have 6 45s, that's 93 times, right? About 270. So where am I going to put the decimal so that I have a number closest to 270? Right there? Right there? No, right there. Now you could have gone, well, I have 2 decimal places here and 2 decimal places here, so I need 4 decimal places there. But we're just estimating to help us place the decimal. Does that make sense? Okay.
So, okay, the math and like everything you're teaching makes sense.
Okay.
So now what I'm confused on is you get 2 completely different answers, especially when you're dividing. Like over here, for this problem over here, you have, your answer is 361.20.
No, that's the answer to this problem.
Mm-hmm. Yes. But when we do the actual dividing in that, like the way that at least I was taught, by moving the decimal places, you get 3,612.
No, you don't. No.
Okay, then I'm.
Move it 2.
Mhm.
Move it 2. It's just that when I told you to punch it in, you got a decimal right there because you didn't have your decimal in this one. But if we do this, we'll get a 3 here, right? 3 times this is 1 on to 0, carry 1, 4, right? 8, 7, 6. Then I go again, I'm going to get a 6. Multiply that, 0, get a 3, 1, carry 2, it'd be 8. That's 66, bring down my 5.
Okay, that makes sense.
Is that right? How am I going to get a 1 here? Have I made a mistake?
The 487 minus 405. You didn't subtract the 5.
40?
It should be 826.
361 times 2
2,
is 700.
6.
There you go.
There we go. So that's not a 6, that's a 1. And 135 goes into 165 once, and so on. And there's my decimal.
Okay,
So you get the right thing.
okay.
I guess what I'm trying to teach you is, when you get done with your answer, see if the placement of your decimal makes sense with the original problem just by estimating it.
Okay, that makes sense now.
Okay. We've got one last thing we need to do, and then we can answer some questions on the test. On your homework, there was a table. And I think it's really critical that everybody understands the concepts behind it. It was like an addition chart or a multiplication table you memorized or used in elementary school. But it wasn't multiplication and it wasn't addition, it was what? Somebody have that there handy that could pull it up, or I can pull it up if somebody's... Yes, can I just borrow that, please? I'll duplicate it. The operation is not add or multiplication like we normally do, it's a star. And then we had a pentagon, a diamond, and a triangle here. We had a pentagon, a diamond, and a triangle. And then it filled out, it had these.
So it's like everybody else turns it, or something.
All right. And we ask, is the given set closed under the operation called star? Yes or no? And how do we know? Yes? Stephanie, how come?
Because if you look at like the results of doing this operation, all of the shapes, they're still the same as your original 3 shapes that you used. None of them are different shapes.
So I've taken this set of 3 objects, symbols, and I've started with the same thing in that set, and every one of my results is from that set.
You drew one of the shapes wrong.
Did I?
Yes, the
Oh.
bottom right corner.
This is what?
It should be a diamond.
Thank you. Yeah, that wouldn't have made sense at all. Thank you. What would it take for this not to be closed? What would you see if it weren't closed?
Circles, another shape.
Yeah, inside here, we'd have a shape that wasn't one of these, like a circle or a anything, a rainbow. Okay. The next question was what? Is the operation called star commutative? What does that mean? Well, if we let this be our first, I was going to say addend. We can't say addend, we don't know if it's add. We can't say factor because we don't know if it's multiply. But our first element in our problem, and this was our second one, if I do, for example, a diamond, star, triangle, according to the chart, if this is the first one, diamond, star, triangle, I get a pentagon, right? So if this is commutative, what would I find? Triangle, star, diamond better be pentagon as well. Now I've got to go to my first element, let it be the triangle, let my second element be the diamond, and this time I get pentagon. What does that tell us? That it's commutative. Does that make sense? Is there any other way to tell this is commutative than other than write a couple of statements down like this and switch the order to see? Yeah.
There's a slight pattern. So with the pentagon from the first element and the pentagon from the second element, it's a pentagon, and then the next two are diamonds, and then the next two are
The next two. Come up here and point to where what you're talking about.
Okay.
See if you can follow what she's saying.
So since, like, I kind of just ignored these, but it was just easier to describe that way, but you start with a pentagon, then you go to two diamonds, and then you have three triangles, then you repeat the pattern, but you go back to two pentagons and then a diamond. So it's just like, if there were more elements, it would be a bigger, different answers. But like, so you have one pentagon, then you have two diamonds, three triangles, two pentagons, and one diamond. So it's just kind of like 1, 2, 3, 2, 1. Like there's a slight.
Everybody follow what she's saying? If we're to make one a little bit bigger with numbers, do you want to use addition or multiplication? Can't use subtraction or division because it's not commutative, but let's do multiplication. Well, let's do addition here real quick. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. We have 0, 1, 2, 3, 4. And this is 2, 3, 4, 5. 3, 4, 5, 6. And then we have 4, 5.
It forms a pattern by just looking at a diagram.
If I look at this diagonal, I see that what?
All the threes, all the numbers line up with each other.
There's a mirror image across that diagonal, right? Does that make sense? So across here we have these two. Here, here, across this diagonal that we've got, which is another way to tell if it's commutative or not. Because this is saying, if these are in the same order up here as they are here, we go this one times this, we got that. The other one is just, you see how it matches up? Okay, what's the next question?
Yeah.
Is it associative? Well, associative, we're going to need a and let's do pentagon. And we want to know if this is the same as this, right? Same order, but different grouping. Well, we already know the answer to this. It's pentagon, right? So if I do pentagon star pentagon, what do I get? Pentagon. So this whole thing becomes just pentagon, right? Pentagon star pentagon. Let's do this one. Triangle star pentagon is triangle. So now I have diamond star triangle, diamond star triangle, and I get what? Oops, diamond star triangle star pentagon is triangle, right? And now diamond with triangle, oh, is pentagon. So guess what? It's commutative, right? And here's our proof, right here. We okay?
Yeah.
What's the next question?
What is the identity shape, and how do you know?
What's the identity shape?
The identity shape would be, okay.
I have a question. What exactly does that mean? Like, what exactly?
What's the identity? We've talked about it.
So what makes it 0, or what makes it? Because I don't know. I guess I don't get the question.
What did I tell you to memorize for the word identity? Do nothing. So what is the do nothing shape? When I star with what shape, nothing happens. Pentagon. I take pentagon and star it with pentagon and get pentagon. Take diamond, star it with pentagon, I get diamond. If I take triangle and star it with pentagon, I get diamond. It appears that pentagon does nothing when I star with it. Does that make sense? And we could try it this other way. Pentagon starred with pentagon is pentagon. Pentagon starred with diamond is diamond. And pentagon starred with triangle is triangle. So the fact that this row is the same as this row tells us that that is the do nothing. Or the fact that this column is the same as this tells us that this one is the do nothing. Does that make sense? Because when I star with pentagon, nothing happens. I can take any other element and star it with pentagon, and I'm always going to get what I started with. Nothing's going to happen. Nothing's going to change.
What would be an example of that with numbers? Would it just be 1? Is that the only option?
1 if you're multiplying, if star is multiplying. But if I'm adding, then it's 0. And if I'm doing something else, then we've got to think about what that something else is. And we're about to go there in a few more days. Is everybody okay? What was the next question?
What is the inverse of triangle?
What's the inverse of triangle? Well, in order to answer that, we have to know what the definition of inverse is. Right? What is it?
Inverse is what takes it to the do nothing.
What gives us, yields, or equals the do nothing. What's the do nothing here? The pentagon. So the question I want to ask is, if I'm trying to find the inverse, what'd you say? Triangle? The question I'm asking is, if I have triangle and I star it with its inverse, it will give me what? The pentagon, because the pentagon's the do nothing. And if I can find this number that yields the identity, I will have found the inverse of triangle. Does that make sense? Now, how do I find that? I go over here and take the triangle and go out here until I get to the identity and say, what produced that? Well, it was diamond. Diamond must be the inverse of triangle. Why? Because when I star it, I get the identity. And that's what the definition of an inverse is.
Why do you start with that triangle and not the top triangle?
You can start with either one.
So if you did that triangle, you'd go
This
down
triangle and come down until I get to the identity,
Oh, it makes
and
sense.
it was diamond that produced that.
Okay.
Yeah, the inverse should work in either order, so it doesn't matter where you start, on the side or on the top. Do we have time for one quick question from the test, if somebody's got one? If you don't want to have a question, I want to talk to you about the second bonus. Second bonus. If you climb up 1, or climb up 3 and slide back 2, where are you after day 1?
You're at 1.
At 1. Okay, so I slide up 3 on day 2, slide back 2, I'm at 2. So it appears that every day you're making how much progress? 1. So to get out of the well that's 20 feet deep, the first thought would be that you're going 20 days. However, start with me. I'm on day 16. Where am I at the beginning of day 16?
Around 16.
15, right?
No, you would be at 16, because every day you progress 1.
At the end of day 15, at the end of day 1, I've gone up 2, back 1. So at the end of day 15, I'm at 15.
Right.
So on day 16, I climb up to where?
17.
18, 3. Slide back to 16. Now it's the end of day 16. Day 16, or day 17 comes, I climb up. I'm at 16, I go up 3, right? I'm at 19, slide back to where? 17. At the end of day 17, I'm at day 17. The next morning, I climb up 3 and I'm out.
So what was that screen?
Right?
I knew it was too easy.
A little twist on it.
See, I did the number line this way.
No, I
And then when I
The cookie one?
down 1.
Yeah.
First it looks like 20 days.
How many got 72? That was a really common answer. But if you take 72 and do what you need, what you says to do with it, you don't end up with what happened.
72 can only go
Right? Okay. If you got 72, listen.
So I got like the 10.
The first person comes along and what? Takes half of the cookies. Eats them or takes them, but we're now down to what? 36. The next person takes what? What's a third of that? 12. If a person takes 12, what's left? There's 24, right? The next person comes up and takes a fourth. What's a fourth of 24?
I think so, yeah.
6. So if they take 6, you've got 18 left. Now what happens? Somebody comes up, takes 1 cookie. Now you're down to 17. And then what? There should be 2 left, but I've got 17 left. 72 can't be the answer.
The trick for that one I found was doing it backwards. Yeah, that's what I did.